So here we have a top view of the Irisbox PC, in which we have removed one of the covers located at the side, and we have complete access to the three boards that integrate the unit. Right here we can see the system on module board, the CPU, with the processor. In this case it is an NVIDIA G20 A9 ARM processor. Behind it we can have the connectivity board providing video, USB, audio, Ethernet, RTC clock, battery, and power supply for the whole system. And at the bottom of all the units, all the configuration, we have the third card, which acts as a carrier board also, which is the input and output board with an industrial format. That's what we call the TESDA board, and it provides 4 digital inputs, 4 configurable digital inputs and outputs, which can be configured one by one as independent input or output, and 4 analog 4 to 20 milliamp 12 bits resolution analog inputs. In all cases of the inputs, doesn't matter they are digital or analog, the TESDA board provides 18 volts supply for the detectors or sensors we connect. Okay, at this side of the TESDA board we can see the 4 relays for the digital outputs with a switch power of 6 amps, okay, providing one normally open contact, right? The state of these relays can be monitored throughout the LEDs located just in front of each relay. Also, we have here the group for the monitoring of the 8 digital inputs. If we press one of the push buttons, we can see the LED, which is monitoring the state of the signal. Okay, we can follow with different push buttons, right? In all cases, the TESDA board provides electrical isolation, and it is important to take in account that it's been designed from an industrial point of view and is designed for using in a very harsh environment. Alright, we can also connect 4 analog inputs, and we can have also, if we generate an analog input, okay, we have for each input 1 LED, which intensity is proportional to the level of the signal being input. Okay, the higher signal I introduce, the brighter the LED leads. So this is roughly the aspect and the configuration from a hardware point of view of the TESDA board. The connectivity is done using these detachable connectors, allowing a very easy removing of the unit or the maintenance of the system. The cabling is very easy because all the connector, the male connector, can be removed, and since it is a press clamp connector, it is very easy just using a simple screwdriver to plug or unplug the cables. Once we have connected the different cables to the physical inputs of the connector, we have just to push the connector until everything is pressed, and we get a very rough and sure connection of the system. We can have also two different LEDs providing indication of the auxiliary power supplies. In both cases they provide around 3 amps of current, and the voltages are in one case 3.3 and in the second case 5 volts. So this is everything for now. We will continue with software, a video concerning a description of the software to control and test the TESDA input and output board. Thanks very much.